Well, it worked. But let's go into what didn't work. What didn't work was this little 10 amp power supply. Worked great on 4 cells, 280s, as long as they had a head start as far as a charge to begin with. So you get them up to about 80%. And we did about the same thing with this. This is the first batch of 16. There's another batch being readied up right now. And we were going to try to top balance these. We ran them up to 80% charge with the MPPs and ran them up to 80%. And then we proceeded to use those wires you see right there. These right to that 10 amp because I didn't want to lose any current. I had the wire. Hey, I'm going to use it. I knew the little banana clip wires come with it are a joke and wasn't going to go that route, especially with these. And these batteries, basically, even though they were at 80% charge, were laughing at that little pathetic charger over there. They're saying, nah, not happening. Wasn't going anywhere. There was no progress. And since I'm not a patient guy, decided to try something else. So, decided to get this system here. Used a Variac, microwave oven transformer rewired to a bridge rectifier. And then we were going to try to use this other Variac as a current limiter, inductance. And that was a total fail. I was getting some crazy results before I hooked it up to the batteries, of course. But we're getting some crazy results. Not going to go with that. So we decided to try something else. So I went back to this, into the transformer, out the bridge rectifier, and found these power supplies or little current limiting units here. Constant current on Amazon, about 6 of these little puppies, and wired them up. See the little holes? I wired them all up nice and neat on this board. And before I powered them up, each one, I set each one up, set them at 10 amps instead of 20 amps. Be a little conservative, take it a little easy. So I had a total of 60 amps output at the 3.65. And each one worked beautiful by itself, but when I wired them together, something strange happened. They didn't want to work together. I have a feeling some sort of crosstalk was happening, even though the inputs and the outputs I filtered with these capacitors, and that was a fail. So I decided, well, we're going to go another route, and this kind of worked actually reasonably well. So I bought one of these little devices here on Amazon, and you could set that. It says 3.42. Don't believe it. The voltages on this thing, you have to make a cheat sheet. What equals what? That also for the shutdown voltage. This controls this little relay over here. And there's a current here, current sensor here. And then you have the wires running over to your batteries. These little fuses here, because I don't want any. There's got a 1 amp fuse in each one of those. So that just senses the voltage up to this unit. It has its own 12 volt power supply, actually 13 volts, going down to operate this system separate from everything else. And that relay will control the transformer. Basically just turns it off. And that seemed to work as long as you got a cheat sheet, what voltage equals what. So you're going to use on these inputs here, I use that power supply to simulate my shut-off voltages, and that actually worked. So what the way I was doing it was I was going to charge it up to 3.4 volts. After these are already charged up in series, brought them all the way up to 3.4 volts again, and let it taper down. I slowed it down and then let it shut off. I didn't have to always be around because this was my backup for me not being around right in the vicinity. I'd be checking it every hour or so and just keep tabs on this because I don't trust it. You know, it's just too much money involved here. Then I would set it up at 3.5 volts and basically do the same. I see it coming up, voltage getting close, back off on the current, the voltage through this, and I'd put an amp meter clamped on here and check that out and see what's going on and repeat it. And again, we did it at 3.6. Each time we did a shutdown, I'd loosen all these bus bars here and see if anything was moving. I didn't want to put any stress on the terminals. And there was 650 pounds of pressure squeezing these cells through that die spring that you see down there. And then we were checking to see movement, and there was a little bit of movement. You see a little pen mark there. This one had a little bit of movement. The wood absolutely had moved a little bit, expanded. A little tick mark on this side here. Also, you can see it has moved. So we are happy that the system was working. We didn't have this thing rigidly boxed up, so it did allow some movement, yet kept a known amount of pressure on these cells, what they recommend. And we have a little silicone barrier. That's a white strip you see between all the cells. And as you can see, they really haven't expanded. They're reasonably close together. I'm really happy about that. They're less swelled now than when I got them. And all the little burst discs all look about the same. They don't look like any of them are under a stress. Manufacturer recommended doing that, and they seem to be right. So at any rate, go into this microwave oven transformer. You can go online and look up microwave oven transformers, or MOTs, and see how people rewire these. This one here happens to be wired up with a 14 gauge magnet wire times 8. There's 7 turns through here, and coming up to this rectifier here, and it's cooled. Have to have a fan on it, and the extra air just goes through, cools the transformer. It never got over 160 degrees Fahrenheit. That's with 100 amps output here. It's 7 amps going into it. I put a 10 amp fuse, and there's a fuse at this end here. That's for safety for short. And there's a 200 amp fuse right there. Just want to be careful. You got a lot of capability there of probably a few thousand amps short circuit there. Don't need a fire, so fuse everything whenever possible. Anytime you lead away from big battery, one way or another, fuse it. I got it all fused up here. So the next step is I'm going to be putting this back into series. Use my jumpers and all of my balance leads. I'm going to put them back up. This time I managed to number them, and so I don't have to follow them all the way back up to the BMS, and that should be easy enough. So that's where we're at. Learn from my mistakes, or what you can do is build your own, maybe a solid state unit, better designed than this, that can regulate a current regulating power supply, constant current system. They have them on eBay, but you're looking at probably a couple months out. They're all in China, and they're good. The ones with the 2 knobs that you might find out there, they're running a couple grand or so by the time you show up on your doorstep. And I don't even know if they work, because I found that I bought a few of these off of Amazon, and their current would fold back way before they were supposed to. This little unit was a jewel. It did perfect, but some of the ones I bought, I had to return them. They just folded back. This little unit here on Amazon, I can't recommend it. I bought a few others to try, but I'm only going to use it one more time, hopefully, to charge the other group of 16, and then we'll put these all together. I'm going to put the cells that we're running high and those cells running low, pair them up for the 2S16, I'm sorry, 2P16S configuration, and we'll run them all through the VMS. That's all I got for now.